Now next topic, that is angular acceleration. Now see here, suppose instantaneous angular velocity is at time t and t plus delta t are omega and omega plus delta omega. So here we can say this thing, the change in angular velocity in time interval delta t, that is delta omega. So as per definition we can say average angular acceleration, that is change in angular velocity upon time interval. So we can write average angular acceleration, which is represented by alpha, that is delta omega by delta t. Now again if we take here limit delta t tends to 0, then we will get the instantaneous angular acceleration. So angular acceleration, that is limit delta t tends to 0, delta omega by delta t, or we can write vector alpha, that is d omega by dt. Now here the direction of alpha, now be careful here, very important thing. It is not necessary alpha is always in the direction of omega. You have to remember this thing. It is in the direction of change in angular velocity. Change in angular velocity. Okay? No doubt that will be also along the rotational axis, but it is in the direction of change of angular velocity. I represent that thing. See, now here if you write the unit, then radian per second square or rotation per second square. Now see here, suppose at time t, this one is omega, right? Direction, and as per its magnitude, we take the length of the vector. But now suppose, see, body is rotating like this. See my finger. And then after some time, it rotates like this. Now you can understand, magnitude of velocity increases but the direction is same one. So you can represent new angular velocity omega dash like this. Now if you take change in velocity, then omega dash minus this one, so you will get omega dash minus omega, that is in the direction of omega itself. So now direction of alpha, that will be also this one. Okay, but now think opposite. Suppose this one is your omega. Again see, body is rotating like this, but then after like this, means slow down, right? Direction that will remain same one for omega, but when it is slow down means magnitude of the angular velocity decreases. So now second vector that you can represent like this, omega dash. Now omega dash minus omega, so you have to take minus omega in opposite direction. it implies that now this will be your omega dash minus omega. So in this particular case, the change in angular velocity, that is downward, so your alpha, that will be in downward direction. So here your alpha, that is not in the direction of angular velocity, but it is in the direction of change in angular velocity. Clear to all of you?